In question number 103, the major product formed in the following reaction is. So in this reaction, basically the hydroxyl group will make an attack on the docile chloride, and the structure of the molecule that will be formed will be something like this. Okay. We have methyl over here, the hydrogen, and that becomes OTS. Now the next reagent is indicating, that is the NaOET is indicating that the reaction will follow a elimination type of mechanism. For that, we have to switch the positions of the groups over here. So we'll keep the hydrogen in an anti-position to the OTS. For that, we will simply rotate the molecules over here. So this becomes methyl, that becomes phenyl, and that becomes hydrogen. This is your OTS. This is your methyl. All right, and that is your hydrogen. So now in presence of OET minus, this will be taken up, that will go in here, this will be your leaving group. So the product that will be formed is an elimination product, and that we will say, obviously, pH will lie behind, Me in the front, Me in the front, and hydrogen back. So that should be our product, and if we just match, then we will say our answer over here is going to be C. Next is 104. Which one of the following bromides cannot form an alkene by E2 process? So out here, let's just draw the structures. Okay. So if we draw the structures, we find what? This is the first one for A. Now for a E2 process, we need a hydrogen at the beta carbon. So if this is the alpha carbon, this is the beta carbon. So obviously this one cannot go in E2 process. For B, the structure is something like that, and obviously it can have hydrogens here, also here, so it can undergo E2 reaction. We will say yes. For C, let's see, the compound is that one, and again it has in the beta position a hydrogen, so that too can undergo a E2 process. For D, we have this as the structure, and again, as we can see, this is the alpha, this is the beta, so it will undergo the E2 reaction. So answer over here is going to be option A, that does not undergo the E2 reaction. Next question is 105. The major product formed in the following reaction. So over here it is basically Hoffman elimination reaction. This is basically Hoffman elimination, and it leads to the formation of least substituted alkene. So let's draw the compound. So this is the alpha and that is the beta position. So we can take out the beta hydrogen either from here or from here. So in the mechanism, what we will show that the OH group will take up this hydrogen, then that goes out and the nitrogen gets neutralized. So over here our products will be the alkene as this, and along with that we have the dimethylethylamine being produced. So over here the answer for the alkene will be option D. Next, in the reaction 106, we have been given an alkene. So the ene bond will get attached to the proton. So that would mean we will have the following intermediate over here. Okay, this is a 2 degree. All right. So this is 2 degree. And now this particular ring will undergo a ring expansion. So we will have a 5-membered ring being formed over here. So there is a methyl and there is a methyl over here. And since the bond is breaking from here, so we will say the plus charge is going to be here. And now the Cl, which is the in the medium, will act as a nucleophile with attack over here. And so our product will be having a structure as I'm writing something like this. And if we match, then we will say the correct answer over here is going to be C. Now, question number 107. The major products X and Y formed in the following transformations are, we have to find out. Okay. So over here, what we will do, we'll take the molecules and we will add HBr. So this is basically undergoing electrophilic addition reaction. So over here, it adds the proton. So over here, we are having a positive charge generated in such a manner that it can be resonance stabilized. Okay, so the lone pairs on the oxygen can provide a resonance stabilization like this. Apart from that, there can be another carbocation generated over here, which will be of the following manner, but this is less stable, and because of resonance, this is more stable. Okay, and similarly, then the Br addition will take place over here like this. So for X, the product formed is this one. Let's check what product will be formed from. Sorry, this is not X. Our X is this one. This is our X. Okay. So from this molecule, if we add HBr, again we have to think in terms of electrophilic addition reaction. So we have this. Now in this case, the proton, when it adds over here, we have positive charge over here, and when it adds to the other ene carbon, then we have the positive charge over here. Okay, so that way if we consider among the two which one is more stable, we will say This is more stable because this is having minus I effect, okay, and far away the electron withdrawing group lies away from the carbocation. That makes it more stable, so this is less stable, okay. So that means now the Br will obviously attach or react with the carbon that is more formed in the medium. So over here, when the Br attacks this carbocation, the product that will be formed, we will say, is going to be this one. Now, if we compare, then we will say the correct answer over here for this will be obviously B. Next, 108 question given is the major product formed in the reaction of 3-propyl phenyl propene with HBr in presence of peroxide. So this is basically a question from peroxide effect, also known as Karash effect, and product over here is anti-Markovnikov. Okay, that being the case, so it is the 3-phenyl propene means the compound is something like that. So if it is adding with HBr, normally addition of HBr, the Br should have added over here if it is Markovnikov product, okay. But here they are saying it is anti-Markovnikov product, okay. That means the Br addition will take place over here via radical mechanism. So over here the mechanism is as follows. Over here, this is the dot, and then abstraction of hydrogen from HBr will take place, and over here we will say this should be our product. So we will say it will be basically 1-bromo 3-phenyl propane. That will be the correct answer.